Welcome to this module on the two country, one good model. This is a neat model that allows us to explore how trade is conducted between two countries. First, some assumptions. Let's assume there are only two countries in this world. We're going to call those countries home and row. Presumably, home is where we live, and row, well, that stands for the rest of the world. We're also going to assume there's only one good in this world. Let's call that good coffee beans. Further, we're going to assume there are no transportation costs. You can move coffee beans from row to home or back and forth at no cost. And finally, we'll start these two countries in autarky. That assumption will be quickly relaxed, but just as a refresher, when we say autarky, we mean these countries don't trade. To set up the two country, one good model, we need three panels. The panel on the left shows the market for coffee beans in the home country. The panel on the right shows the market for coffee beans in row. And the panel in the middle is called the international market, and that's where these two countries interact, where coffee moves from one country to the other. Let's start by looking at the home market. As would be expected, we see this upward sloped supply curve, labeled S, and this downward sloped demand curve, labeled D. Those two intersect at this point, which we call equilibrium, and if left alone, in autarky, the home market would have a price for coffee beans of around $7 per pound, and we denote that by labeling it PA, which is the price of this good in autarky. In the row market, we see an upward sloping supply curve labeled S star. The only significance of the star here is that it denotes that we're in the row market. We see a downward sloping demand curve labeled D star, and again a point of equilibrium, which gives us a price of $3 or PA star. We'll call that price PA star. Right off the bat, we should be able to make one observation here. Somebody somewhere is going to say prices of coffee are selling at $7 in the home market and at $3 in the row market. And if that's true and transportation costs are zero, then I should be able to buy coffee in row and bring it into home and make $4 per bag. And if you were to do that, you would be engaged in what's called arbitrage, the formal definition of which is the act of simultaneously buying and selling a commodity in two different markets. For our purposes, we can simplify that by saying that you would buy low and sell high with an aim of making a profit. Now let's see how much coffee would be moved from row to home. To figure that out, start by looking at the home market and finding that point of equilibrium. We can see that point right here. From there, trace your finger over to the international market and find the equilibrium price in the home market, that price of $7. And there, place a point on the y-axis. That point shows the amount of row coffee that would be demanded in the home market if it were brought there. So for example, if you were to get some coffee from the row market and bring it into the home market at a price of $7, nobody in the home market would want any. They would argue instead that all of their coffee needs are already being met at $7, which can be seen at this point. Domestic supply equals domestic demand at that price. However, as price fell and as price became lower, then demand would start to exceed supply. So for example, you can see this distance here at a price of just $1 lower, or $6, demand is 4 units and supply is 2 units in the home market. So that suggests there's demand for 2 extra units, and those could be provided from row. So at a price of $6, find the spot where 2 units occurs, which is that dot right there, and mark that point. Continuing this analysis, let's go to $4, where we can see that at $4, domestic supply in the home market is 0, and domestic demand in the home market is 6. So at that low price, 6 units are demanded and none are produced. So find $4 and find the point where it intersects with 6 units and place a dot there. Once you've placed those 3 dots, you can then connect those dots with a downward sloping line, and we'll label that line DM. That's demand for imports. That shows the amount of coffee that people in home want at an array of prices. Let's do the same analysis now for the supply of imports. If you were to offer people in row $3 for a pound of coffee, they would say, we're already selling coffee at $3. If you want to buy coffee for importation into home, you'll have to pay us more. So at a price of $3, they would be interested in selling you 0 coffee. We can mark that point here. At a price of $3, supply of imports would be 0. We'll mark that point, not a very good mark, but somewhere right around there. Then, as the price went higher, we would see that supply drifted away from demand. In this case, it does so at 2 units. At a price of $4, then supply is 4 and domestic demand in the row market is only 2. In other words, that distance is 2 units. So at a price of $4, go up just $1 from $3 there, place a dot at 2 units. We can continue this analysis at looking at this market at $6, and we see at $6 domestic demand is 0, and at $6 domestic supply is 6 units. So at a price of $6, we place a dot at 6 units. That's the distance then here between supply and demand at a price of $6. Once you have those 3 dots, you can connect them, and we'll label that supply of imports into the home market. I've cleaned this up a little bit, but now we can see more clearly written supply of import and demand for import curves. And in the international market, we find that those two intersect here, and that's the point of equilibrium in the international market. So from that, we can then conclude that 4 units would be purchased in row and brought into home for imports. Further, we can then speculate on the price. If you find that point of equilibrium and then track it to the y-axis, you can see that the price would eventually become $5. And this we're given from the law of one price. As coffee is purchased in the row market for importation into home, it would drive that price higher, above 3. And as coffee moved into the home market from the row market, it would drive that autarky price down from $7, and eventually it would settle in at an equilibrium, what we call a world price, or PW of $5. And once you have that, you can draw a line across all 3 graphs. That would be the price that coffee would sell at in both of these markets. From there, you can have one more check to determine that you did all this correctly. If we are seeing that a world price of $5 would develop, that's this, and 4 units would be imported from row into home, we should be able to confirm that in both markets. And indeed, we do see that. At a price of $5, we see 1 unit is demanded domestically, and 5 units is supplied domestically. So that means there's 4 extra units produced in row, and those 4 units are produced for exportation into home. Similarly, we can see at a price of $5, 1 unit is supplied by the domestic producers, 5 units is demanded by the domestic consumers. So if only 1 is produced and 5 are demanded, well then these other 4 would have to come from somewhere else, and in this case they would come from the row market. They would be imports. So then we've seen that the 4 extra units that are demanded in the row equals in home equals the 4 extra units produced in row, and that all equates to the 4 units that we see moving from row to home in the international market. All 3 of those check out.